This video is a continuation of a previous video where I have compared 8 different receivers from a real antenna with a frequency range entering the receivers from DC, well, from a couple of 100 kilohertz up to about 13 megahertz. Now I have inserted a low-pass filter in series here that limits the frequency range to 4.5 megahertz. Means a couple of 100 kilohertz up to 4.5 megahertz. I have also removed this 3 dB attenuator and inserted an amplifier with 6 dB gain at this point. Means there is 9 dB more gain, but the frequency range is smaller. It looks like this. This is the DC to 4.5 megahertz filter, and here is a 6 dB amplifier with noiseless feedback with the MOSFET inside. I am now running the SDRplay, which means you can see the stop button is active. And I can see that the noise figure is 1 dB better than I really want, and I can take that into account. And now I add the signal from the antenna. Oops. And this is too much. 21, 22, 23, 24. Well, 23 for a 3 dB signal to noise loss. So I write 23 here. And then stop this one and enable the FUNcube Pro Plus by clicking here. And the attenuator is still at position 23. I put it to 43 just to check the 0 point, which is here. Now go back to 23, 22, 21, 20. Well, this is 10. Three, 2, so there is obviously some filtering inside this FUNcube Pro Plus, because I only need to attenuate by 2 dB here. 2. So I switch off the FUNcube Pro Plus and start the Airspy plus Spyverter combine. And it looks like this. And this is without the antenna signal. Means attenuation 42, 32, 22, 12, that's not okay. 22, 20. $18, 19, well, 20. So I write 20 here and switch off this one and start the HF plus here. It has crashed. I have to restart it. Well, that was an operator error. I was clicking on the start-stop button here and not on the loudspeaker. And then we have this problem with the video card. What I see here is 0. This is 20 dB. And I turn on more signal. Oh. There is 16. That's too much. 15. So 15 is okay. 16 is not. So I write 15 here. And turn off, well, the loudspeaker. And start that one and turn off the loudspeaker so I won't forget it. And the next one is the Afedri, and it is clear it doesn't like this situation. I reduced the signal, and here there is no interference visible. This is 22 and not acceptable. 23, 24, 23, well, 24. Doesn't sound very nice, but the signal is still visible here, but with the 3 dB, well, a little bit. I decide that 23 is what this can take. Then close that and start the FDM-S1 here. And this is still 23, and 13 is not nice. 16, okay. 15. Has this ugly impulse noise problem. I guess it's something causes saturation regularly. Well, 14 and about 3 dB loss of S over N. So that's 14. And close this. And enable the IC706. And oh, it has drifted in frequency, so I have to move it a little bit. Like that, and then turn on the antenna signal. And here is where it has a problem. Not a severe problem, it's a 3 dB loss of signal to noise. That happens at 4 dB. So I write 4 here and turn off the IC706 and turn on the Perseus. And more signal, 4, 3, 2, 1, 0. Well, so this is the point where it has a problem. I will look at the light on it, and it's not saturated. So I write 0 for the Perseus. And then I will make a couple of more measurements to get something to average, but I will not show all of that in the video. Before continuing, I look at the oscilloscope. We have something here. And it's pulses. I turn down the speed, and we can see that they repeat at about 10 microseconds. That's what is per division, so it is 15 microseconds. Well, I don't know what this is, but it's very obvious. I will look at the spectrum of this. So here is the spectrum now when limited with this low-pass filter, going from DC to 4.5 megahertz. What we see here is the pulses that we can see here also. They are producing overtones in the amplifiers because they are near saturation. But these overtones are suppressed by something like 30 decibels, so compression is not severe. And that's in line with what I could guess. These pulses are probably generated by some power supply here in my house. But that's life for many DXers, that there are interference sources of this kind, so I don't think it is bad for the test I'm doing. I have inserted a common mode current suppressor in the cable towards the antenna to avoid sending this noisy ground from my computer system out to the antenna. And as a result, the oscilloscope looks quite different. I'll turn the trigger here. So this will affect the performance I observe. So I'm now running the SDRplay. And it was 23 dB before, so I put it on 20. Well, that was 20. Well, 20 will be okay for this one. 20. Then switch this off here and start the FUNcube here. And now I remove the antenna signal and I put it back. This is too much signal. This is somewhere in the neighborhood. Uh, 2 dB. So it's the same as before. Remove the FUNcube and insert the Airspy Spyverter, and it was 20, so I put it on 20 again, and it can take more signal now. Not so much more. 17. So I make it 17. And then the HF plus. Here it was 5 dB better. So I turn on 5 dB here. Well, that's too much antenna signal, like this then. Yeah, this is 4 dB. So I make it 15. That's the same as before. So switch that off, and Afedri Net SDR, it's down here. (23) before. So I check the noise floor, which is unchanged, of course. And now I have 20, and it's still okay. 18, not okay. 19, 19 will be fine. So switch off the Afedri and on the FDM-S1, and it was 14, so here is 14, 13, it's now 11, 10, 9, this is too much interference, I think, so I make it 10. And remove the FDM-S1 here and enable the IC706. And it's okay. And it's 9 dB now. 8, 7, 6, 5, 4, 3. Well, I cannot degrade it much. This is 0 and it's a 2 dB loss. So I write that's -1 question mark. And finally the Perseus. Oh, now there was some interference. Oops. Intermodulation from local CW stations. Switch off this and the Perseus. And it's not unexpected that I don't see any interference. Well, a little. Maybe 1 dB. But the Perseus is not affected by this 0 to 4.5 megahertz range when I remove the power supply impulses. It's now 12 o'clock, so the medium wave is gone. What I see here is mainly, or say only, switch power supply interference. When I search with the trigger point, I don't see any sine wave. The filter DC to 4.5 megahertz is in line, and I have extra gain to get to see this. I'm listening to the SDRplay, and I can see here the noise floor is too low, means the noise figure is too good by 2 dB. But I look for a 3 dB change. It's about here, and that is with 25 dB attenuation. If I degrade the noise floor by 2 dB, I would have 2 dB less attenuation here, so I write 23 in the protocol. Then I go for the FUNcube, and I know it has a filter, so I have to give it much more signal. Well, I forgot to check where the 0 point is. And most of all, I forgot to switch it on. Where is the mouse? Like that. And here it is, and it has the right noise figure, and I switch on the antenna signal. This is too much. But this is what it can take. It's a 2 dB loss, but the next step is too much degraded. This is 6 decibels, and you see on the screen that we have some interference. So I write 6 and go for the Airspy Spyverter combination, which we have here. I find it has drifted again, so I have to shift the frequency. And here we have it. And the error on the noise figure is 1 dB. I don't worry about that. And look for when it starts to degrade. 26. So I write 27. I do compensate for the noise figure. Airspy HF Plus. What? It's not giving any output, this one. I have to investigate that. Well, this application has crashed. And when I restart it, I find it has muted the loudspeaker. Very odd. So now I can unmute the Airspy and it works again. Well, Microsoft Windows can also have problems. The noise figure is the right one, and I apply antenna signals. Oops, too much. It has a very sharp threshold at this. Now it is 19 dB. Now it's 20 dB. So I write 20 dB in the protocol. 3 dB loss or less. 20. And then the Afedri Net SDR. This is too much degradation. But this is okay. So that is 26 dB, like before in the night. Well, numbers don't differ much since midnight. The FDM-S1, I switch off this and go on here. And this is 16, 17. So I write 17 here, and the IC 706. And this video card has to be replaced pretty soon. And increase the antenna signal. 7 now, 6, 5, or 6. So it's 6 here. And finally the Perseus. Now I have a lot of attenuation, and then I go for a strong signal. Well, like that, see? And this is 5 dB. So I put 5 here. I have now replaced the input filter and this amplifier and removed that and put some other amplifiers in and replaced the whole thing by a pre-selector 7 MHz center frequency and these two amplifiers. And the situation is now quite different. On the oscilloscope it looks like more or less sine wave because it's only a narrow range that come through here. I start with the Perseus, which is running now, and you can see it runs, well, it did recently. It runs into saturation now and then, but not very frequently. But the measurement is no longer okay, because you can see here I have not enough suppression in this low notch filter. I have to reduce the bandwidth for all the radios and change the settings before proceeding. I have changed the bandwidth of all the receivers to match the new marks here and here, and that's about 1 dB smaller bandwidth, so I have changed that number by 1 dB. And this is done for all the receivers, and that eliminates the problem with signals that are not enough attenuated by the notch filter. This is what I see on the spectrum analyzer. It's centered at 7 MHz and the span is 2 MHz. So we have several strong, fairly steady signals. Here is the frequency response. 3 dB points at about 6.75 and 7.27 where the markers are. And you can see the notch, it is on the side of this filter. So this pre-selector suppresses the broadcast stations a bit above 7 MHz, but it allows the entire amateur band. And the suppression of the lowest broadcast stations is rather small. So this is kind of filter I would use as a pre-selector on 40 meters if the receiver wasn't really very good. I'm now running SDRplay with this limited RF bandwidth, and all the time I have been using the gain reduction here, 59, and it gives a noise figure that is 2 dB too good, but if I increase that to 60, the noise figure becomes 4 dB too bad. So this is the best I can do, and the bandwidth is set properly, and I inject these narrowband antenna signals until I see a loss of performance. And you have it here. Well, about this point. Well, it's a little bit less stable now because it's a fairly narrow bandwidth that enters the receiver, so it varies more with time. But let's say it's 37. Well, maybe not quite. I make it 39 instead. And I have to repeat this several times because of the varying signal levels. So I make it 38. Here is no antenna signal, 39 dB, and here is 40 dB, and it's still set to 40 dB. It's a little bit hard to judge. Well, I make it 41 dB then. Uh, 41. And then I go for the Airspy HF Plus. Disconnect that and connect this. And it is at the right level. I'm still at 31. Well, this is too much signal. Now the attenuator is 22. .24. Well, I make it 25 then. So 25 here. And switch that off. And switch on the, which one? Afedri. Here. And this is with no antenna signal. And here we have some problems. That's 15 dB. So, and now there was some too much signal. So that's 16. And remove this. And I enable the FDM-S1 here. And the noise figure is it's 1 dB too high. Well, 1 dB. And the bandwidth is correct. So I insert the strong signals now from the antenna. And I see more like half a dB, so I forget that. So this seems okay. It's 10 dB. And I switch off this one. and on the IC 706. And I have to attenuate the antenna. To get this reference, and then I want the 3 dB degradation. $18 dB now. And I have to wait a little to be fair in, because I don't know how stations come and go. But this seems right. I write 18 in the protocol and remove the IC 701 and enable the Perseus. And it's like this, and I add more antenna signal. It's clearly degraded occasionally. That was at 3 dB. Now I have 4 dB. And I watch it for a little while. So 4 dB seems to be reasonable for this one. And the table so far. Here is no antenna signal, 39 dB, and here is 40 dB, and it's still set to 40 dB. It's a little bit hard to judge. Well, I make it 41 dB then. 41, and then I go for the Airspy HF plus. Disconnect that and connect this. And it is at the right level. I'm still at 31. Well, this is too much signal. Now the attenuator is 22. $24. Well, I make it 25 then. So 25 here. And switch that off. And switch on the, which one? Afedri here. And this is with no antenna signal. And here we have some problems. That's 15 dB. So, and now there was some too much signal. So that's 16. And remove this. And I enable the FDM-S1 here. And the noise figure is it's 1 dB too high. 1 dB. And the bandwidth is correct. So I insert the strong signals now from the antenna. And I see more like half a dB, so I forget that. So this seems okay. It's 10 dB. And I switch off this one and on the IC706. And I have to attenuate the antenna. To get this reference, and then I want the 3 dB degradation. $18 dB now. And I have to wait a little to be fair in, because I don't know how stations come and go. But this seems right. I write 18 in the protocol. And remove the IC701. And enable the Perseus. And it's like this. And I add more antenna signal. It's clearly degraded occasionally. That was at 3 dB. Now I have 4 dB. And I watch it for a little while. So 4 dB seems to be reasonable for this one. And the table so far. I have repeated now 4 times and taken the average, and you can see the averages in this column. I will now collect the results from these three measurements to do a final comparison on the performance on real antennas with and without filtering. Now I have replaced the antenna with a sine wave from the signal generator, and I have set the level 1 dB below saturation in the Perseus. 1 more dB and it's clipping. And I stepped the frequency 10 kHz downwards. It's now at the center of the notch and we cannot see it. 10 more kHz down is here. And this way I will evaluate reciprocal mixing at a few separations for all these radios. I'm now running the SDRplay. It's the oldest one, the RSP1. And I will indeed have to replace this video card pretty soon. The signal to noise ratio is 2 dB above target, as it has been all the time. And I turn on the signal. That is too much signal. Oh. And here the readings are pretty stable because the signal doesn't vary with time. So these measurements are easier. But of course there is this random noise. This is, well, I have to change it. Well, 1 more dB attenuation. This is pretty much a 3 dB loss of signal to noise ratio, and the attenuator setting I have for that is 55 dB. So I write 53 in the protocol because the noise figure was 2 dB too good. And I continue with the other receivers and the other frequency separations. I don't make a video of that because this measurement is not so interesting. I mean, you don't need to see my judgment of where the 3 dB loss is because it's not varying with time much. So here are the results from measurements with antenna, wide open, low pass filter and band pass filter. And they are shifted for the result of the Perseus to show 0, so you can directly compare to the Perseus. And one thing sticks out, and that's the FUNcube. Obviously it has protection from signals below 4.5 MHz. These ones are wide open, more or less, and also this and that and that. But not the IC706. It seems to have some front-end protection, but not much. And Perseus is the reference. Here are reciprocal mixing measurements. Now, they are all measured with the Perseus at a level of 5. So I will shift these columns by 5 dB. Now, all results are related to the Perseus. Comes as 0 in the table. And there are a few observations. This thing sticks out, as I said before. There is obviously a protection for low frequencies in the FUNcube when it's tuned to 7 MHz. Another thing is that the IC706 suffers from close-range reciprocal mixing. The tuner-based dongles or radios, they have a reciprocal mixing in the range 10 to 200 kilohertz, and the Airspy HF Plus also, but much less as compared to the older tuner-based receivers. And then the wide-open radios, direct converting, Afedri and FDM and Perseus, they don't have reciprocal mixing, or not much at least. The FDM-S1 seems to have reciprocal mixing because this varies with frequency. So this is the final results, and what it means depends on what antenna you have and if you want to add filters in front of the receiver. You can see the reciprocal mixing here. Now there is no signal generator, and I add the generator, and you can see the Airspy Spyverter here. And this is the HF Plus. Very little, but if I go 1 dB above this level, the AGC will kick in and degrade the noise floor. And at this separation I see nothing on the IC706, and of course nothing on the Perseus. But on the SDRplay, we can clearly see the reciprocal mixing, and also, of course, on the FUNcube. The noise floor is lifted by about 20 dB. That's just an illustration of the reciprocal mixing measurement. To illustrate what this really means, I have restored the wide open configuration. Worst is the Airspy and Spyverter combination, nearly 30 dB less good than the Perseus. So I have set the antenna signal, I mean the gain of the system, this system, to present a level that is just below where this becomes degraded. I add 3 more dB, and it's clear it's no good anymore. So what it means, I can look here in the Perseus. The noise floor is minus 120. That's the 15 dB noise figure thing, although I have this weak carrier. So I listen to the noise floor somewhere else, let's say here. And you can see the level is minus 103, roughly. It means that the margin for the Airspy and Spyverter is something like 10 dB. I can reduce by 10 dB here. And of course the level goes down by 10 dB, but it's still well above the noise floor within the notch, which was minus 120. I have a 6 dB increase of the noise, roughly. I can remove the antenna signal. 121 to 113. That's 8 dB. This is perfectly okay. So it's the same for the Airspy Spyverter. So with my antenna, the worst radio of them all is clearly good enough without any filters. And then the Airspy HF Plus is significantly better. It isn't protected so well for the lower frequencies, but it has some protection. Well, this is the data, and I will not talk much more about it in this video. I might say things that are not so well thought after. This can be discussed on the reflector if someone is interested.